Hey class, today we're going to talk about identifying functions. But before we begin, we're going to look at some vocabulary words. And the very first vocabulary word that we have is relation. A relation can be represented by a set of tables, equations, or graphs. The domain is a set of all possible x values. The range is a set of all possible y values. And the independent variable is the same as your x values, and the dependent variable is the same as your y values. A relation is a function if for each x value there's exactly one y value. Each value in the domain of a function is called your input values, and the corresponding value for the range is called your output values. Now that we have an understanding of some of our definitions, let's look at our first example. In this example, they want us to identify the domain and range of each relation. So what we just learned about domain and range was that my domain is my x values and the range is my y values. So when they want me to identify, they really just want me to list them out. So for my domains for my first set, that's nothing but my x value. So I'm going to start with my x. That's going to be -2. That's going to be 0, 4, and -2. For my range values, that's 0, 3, -7, and -1. So here we listed out and identified what our domain and ranges were. So as we move to our next example, they want us to still identify our domain and range values. So if I go through, we just learned domain is my x, range is my y. So in a table it's a little easier because it's already separated by x and y values. So all I have to do is list them. So if I look at my domains, that's going to be -4, -1, 2, and 3. For my range values, what we got is 1, -5, 8, and 1. So these are my list of domain and ranges that I identified from this table. So let's continue to our next example. In this example, they ask us to determine whether the relation is a function and explain why or why not. But before we can actually determine whether it's a function, we need to know how we can identify functions. If you look off here, it says that no x values are repeated. So in order for it to be a function, none of my x values should be the exact same number. Okay, so in order to do that, we're going to go through, we're going to point out all of our x values in this list of relations. So our list says we got -5, we have a 0, a 0, and a 3. These are all my x values. And it says that no x value can be repeated. So in this one, because I have 2 zeros, that means this is not a function. Okay? So no x values can be repeated. So let's move to our next example. In this one, we're identifying whether it's a function or not. So if we're going to identify whether it's a function, we only focus on our x values. So our x values for this one is going to be 2, 6, +1, -1. So because nothing in my x values repeated, that means this one here is a function. Why? Because no values of x repeated. Okay, so let's continue. In this example, same thing, we determine whether it's a function or not. So we go and we focus on our x values. Our x values for this one is -1, 0, +3, +3. So in this one, these 3's were being repeated. And because the 3's are repeated and they're both positive, we're going to label this one as not a function. Okay? So that's how we identify whether we have a function or not, just making sure that none of our x values are being repeated. Now, it says when given a graph or a picture of a relation and asked if it's a function, what we use is called the vertical line test. Okay? This test helps us to know if a relation is a function by looking at to see if the vertical line drawn does not intersect the graph at more than one point. So in other words, on a graph, each x value is paired with exactly one y value. So for these sets of examples, we're going to be practicing what we call the vertical line test. And with the vertical line test, it's same as identifying a function in a table or a list of ordered pairs. We can only have one x values for every y value. But with the vertical line, what we're doing, we're going through the actual image and we're drawing vertical lines down throughout the entire graph. And when we draw vertical lines throughout the entire graph, what we're doing is we're testing points throughout the graph. Okay, so when we test these points throughout the graph, what we should notice is that every vertical line should only touch a point one time. Okay, so if we notice that it touches more than once, that is not a function. So like in this example, we're determining based off the graph if it's a function or not, and based off our vertical line test that we completed, none of these touched a vertical line, because you know a vertical line goes straight up and down. None of them touched a vertical line more than once. So what we will label this one as, this will be a function. Okay? Because it passes the vertical line test. So let's look at another example. So in this example, same thing. We're going to go through and test our vertical line test with the points that they provided. So if I draw a vertical line through the points they provided me, what I should notice after I do all my tests with my vertical line, I notice that in one of my lines it touched there and there. So in this vertical line, because it touched at this point, and on that same vertical line it touched at this point, we're going to have to label this one as not a function because it did not pass the vertical line test. Okay? So that's what the vertical line test. So it helps us on a graph to determine if it's a function or not, and it has to be only touching one dot or one point at one specific spot. If it touches twice, that means it is not a function. Okay, so let's continue on. Let's check this graph that they provided us to see if it's a function. So vertical line test, I go through, test my vertical lines. Now as soon as I notice that it touches one spot more than once, I can actually stop there. So what we should see here is in the very first line that we drawn, it touched that point and this point. Even in the second one, it did it again. It touched it at two different spots on the same vertical line. So because we're touching at two different spots on the same vertical line, what we would have to label this one is not a function as well. Okay? Alright, so let's continue on because that is not a function because it touched the vertical line more than once. Okay, so as we move forward to this example here, same concept, let's determine if it's a function based off the vertical line test. So as we go through, we draw vertical lines throughout the entire graph to make sure that what we're testing is true. Okay, they don't have to be real close together, but as you move throughout your graph, you'll notice that in this one, it only touched each vertical line one time in every spot. Okay, so because it only touched the vertical line one time in every spot, we're going to have to label this one as being a function because it passes the vertical line test. Okay, let's continue. Alright, so the next section talk about mapping diagrams and tables. Mapping diagrams and tables can be used to determine if a relation is a function. In a mapping diagram or table, each x value will be paired with only one y value. Okay, it says a y value may be paired with more than one x value, in the relation will still be a function. Okay, so let's look at some examples of mapping in tables. So let's determine based off this mapping that we have that it is a function or not. Okay, so a mapping is basically two sets of bubbles, one input, one output, and then you'll have lines separating or telling you what is the actual x value going towards which y value. So input, what we learned from the last time, our input is our x, outputs are our y. Okay, so what a mapping tells me is that if I go to 1, this is my x value, and that x value goes to the y value with 0. So that order pair will be 1, 0. This 3 is my x, and it goes to the 6, so the y value will be 6. Okay, so what we look for in mapping is if the x values, the numbers that they gave us, has more than one arrow coming from it. So like this 1 only has one arrow coming from it, this one has one, this -2 only has one arrow coming from it, and this 5 also only has one arrow coming from it. So because each one of my input values, my x values, only have one arrow coming from it, that means this is considered to be a function. So we will circle yes, it is a function, because no x value is repeated. Okay, so let's move on to the next one. So in this next one, same concept. We look at our x values, but this time they didn't label it as input. They actually gave us the title of x. So we have to know that x is input, y is output. So we go through and do our test again. So at this -1, we only got one line coming from it. This 3 has two lines coming from it in my x values. Because 3 has two lines coming from it, that means that 3 was repeated twice in my x values. So that means this one cannot be a function because 3 is being repeated. So it did not follow the rule of only having one x value and none of them can be repeated. So let's continue. In this example, same concept, we look and see what we can determine. So in my input, we got 4 being one time, -1 is only one time, 0 got one arrow coming from it, and 5 has one arrow coming from it, so this one is a function. Alright, moving to the next example. Let's look at this table. Let's determine if this table is a function. In tables, you look at your x values, so your focus is always your x values. And do I have any numbers in my x values being repeated? We got a -6, 3, 2, and a 7. So no value in my x value list is being repeated. So because of that, this is a function. Okay, moving to the next example, number 14. If we look at this example, same thing. We look to see what values in x are being repeated, if there are any. If there's no numbers repeating, it's a function. If it is numbers repeating, it's not a function. So here, when we skim through our input values, we know we got a +4 here and another +4. So because +4 was repeated, this is not a function. Okay, so let's move on to our next one. Number 15, looking at our actual input values, our x. So we got 1, -2, 3, and -5. Nothing in my actual x values were being repeated. Okay, so because of that, we have a function. But remember, your y values can repeat, but your x values cannot. So therefore, nothing in my x repeated, so this is going to be a function. Okay? So we just completed all of our examples about how to identify a function. Thanks for tuning in, and we'll discuss this a little bit more in class.